CRA-Tubulars is a developer of carbon fiber composite spoolable production tubing, claiming to make wells safer, cheaper, and more productive. Before we get into that, let's tell the viewers who you are. Emil is the founder of CRA-Tubulars and has over 20 years experience with non-metallic tubulars in the mining and oil and gas industry. Back in 2009, Emil was the technical director for Akit, where he had a non-metallic casing. In 2001, Emil worked with spoolable tubulars at Aptic. Aptic bought the assets of the Norwegian company ABB Compipe, a pioneer in non-metallic spoolables. Emil is known for his expertise in composites. So Emil, tell us a little bit about your professional background.
Thank you for that intro, Fred. Actually, I started my professional career in shipping, so nothing tubular at all. But I quickly found out that that was not the place for me to be. So after 5, maybe 6 years of working at sea, I decided to work ashore, and that's where I came into contact with the first composites company that I worked for. That company made composite glass fiber reinforced flanges for large diameter pipes that were used in sewage. And that allowed me to get to know the industry a lot better, and the industry got to know me as well. From that position, I transitioned to founding my own company, and I promoted myself to pipe and tank consultant or specialist in composite materials, and many interesting projects passed through that company.
Was that Sandrak?
That was Sandrak, correct, Fred.
Very good. We see that in your LinkedIn profile, so just wanted to make that connection.
Yeah, it's the company is still in existence, but its activity have changed dramatically. Mainly because in 2009 I got into contact with a group of people that worked on composite casing. They were old Shell and Deutag engineers, and they were already running a project back in the day to develop a composite casing product. And at that time they asked me to make a review of the technology, where they stand and how they could push the project forward. And I did just that. I made a report, and basically the conclusions in the report were quite clear, and it led to them hiring me as their technical director for the project. And I stayed almost 10 years with them.
So that was Akit, right?
Yeah, that was Akit, correct.
And Akit was focused, I'm sorry, Akit was focused mostly on casing and drill pipe. Was that correct?
Not drill pipe, but it was actually just casing. There were other slight side steps in drill pipe, but that was actually not done by Akit. It was other companies that did that work.
Okay. So why did you switch focus from casing to tubing?
Well, actually, because what I have learned over those 10 years in Akit, of course, when you try something as innovative as developing composite casing, there's a lot of things you do right, but there's also a lot of things you do wrong. And one of the things I learned, that in order to achieve the performance that is required for any downhole tubular in a composite material, you need to have the best performance that you can get. And that means employing the best and also most expensive materials that you can get. And when you're making a casing, that is not so easy, because the material usage for a casing is, of course, it's a larger diameter pipe. So the material consumption is exponentially bigger compared to a small diameter pipe like a tubing. And therefore, using those very advanced space age materials, so to speak, means that immediately the business case behind something, the business rationale behind something like that is broken, because the material cost is prohibitive. So that was the most important learning from the Akit period, that in order to get the performance you need top-notch materials, and you can't afford too much of it. And in tubing, that's of course a whole different story. In tubing, it's a small diameter, low material usage, and when you use aerospace grade epoxy resins, which are 4 times more expensive than industrial epoxy resins, or when you use carbon fiber instead of glass fiber, that will not break the business case. It will actually make for a very attractive proposition for the customer as well as the company providing the product. So that is a very important driver for the switch from casing to tubing. There are more drivers, but perhaps it's not a good idea to get into all of those details today.
Right. I imagine it's a little less risky too for those that are first trying a new material like this. So we're focused on tubing now. So what does this tubing solve for the end user?
Again, there's a short answer, there's a long answer, but a very important driver, of course, is the cost of a completion. And in many instances, our tubing is a lot cheaper than the alternatives that are used in this market. Obviously, carbon steel is still a very widely used material, but as soon as you run into any kind of corrosive environment, then often materials like chrome 13 or duplex steel are used, or even much more expensive alloys like Inconel or stuff like that. And our tubing is priced anywhere between chrome 13 and duplex steel, so it is not the cheapest pipe out there. But the big difference is that our pipe will last the life of the well. The corrosion resistance of it is so good that you will never have to replace it again, basically. And in the long run, that makes it a lot cheaper than, in some cases, even carbon steel. Because if you're replacing carbon steel, say, every year or every 2 years in your well, then you're looking at 10, 12, 15 workovers over the life of the well, at least. And another interesting feature that we bring to the market is that we can repair wells quicker. If you're an operator and you're using high alloy tubing, then the delivery delays is significant. It's not uncommon to have 9 months delay or sometimes even 18 months delay before you can ever actually have, say, a duplex tubing string. And then you also have to mobilize a rig, which also is not an easy thing to do. So if you have a well that is shut in and has to be repaired, you're losing cash flow every day. And every day that takes, that you have to wait for tubing to deliver, you're hurting. You don't want that. Now what we do is we aim for local production, and we can manufacture a string of tubing in 6 weeks. It's a very different number. And also we can install it with a hydraulic workover unit instead of a rig. So we think we're able to bring a well back online within 2 months, maybe a little bit longer, but that's it. And that's a major advantage to an operator, obviously. And then, of course, I already mentioned fewer workovers because the pipe simply lasts the life of the well. And with fewer workovers, you also have a very positive effect on your health and safety records, because if you have no workovers, you don't have any spills, you don't have any accidents, you don't have any workers in the field that can get their hands caught in anything. So it is an added safety bonus that doesn't cost you anything. So we think we're in good shape to bring those things to the market.
Yeah, you stole my thunder a little bit there. I was curious to know what they do now instead of using carbon fiber pipe. And as you point out, they use carbon steel, they use chrome 13 or even Inconel. And if they do nothing, you just listed a litany of problems that can happen from loss of production to the enormous overhead cost of multiple workovers, and not to least mention the opportunity for your employees to be injured with all those interactions with the well that were probably unnecessary if you went with this type of a tubing. Is that correct?
Yeah, absolutely. Simply fewer actions in the field means fewer accidents, as simple as that. And surely there are companies out there that have a flawless safety record. Yeah. But I mean, anything you can do to improve that is probably very welcome.
Exactly. So that'll have major impact on the OPEX. If operators switch to CFST, which we for short will call the carbon fiber spoolable tubing, if they are to change to that, how will that change the operations in the field?
we foresee several things happening. One thing that we actually didn't expect initially was that we give operators the opportunity to be more flexible in their well planning. I mean, I'm sure you're familiar with it. You're exploring a field. You have a situation where the pressure is still on the formation. You're producing nicely, but over time that changes. And say after a number of years, you will have to start doing some injections, some stimulation, and of course it deteriorates from there. And oftentimes when that kind of thing starts happening, there is still 60, 70, maybe even 80% of the reserves is still in the ground. Now, when you have completions in your well that are fully corrosion resistant, you can basically decide at will to convert an existing producer to an injector. And even today, that is something that is sometimes done by companies, but it has a very adverse effect to the life of the tubing. If the tubing is designed to withstand fairly clean hydrocarbons, and then all of a sudden you start injecting high CO2 loaded water into it, chances are that the tubing is going to fail within a year.
Yeah.
Now, if you can anticipate that kind of thing without any problems because you have already taken care of that by your initial design, that opens up a whole new bag of tricks for field exploration. And that's an unexpected bonus, actually, that we think will be important for customers.
Oh, very good. So it sounds like a wonder tool for a very difficult operation. To handle a production well that you can turn around and turn into a stimulation well or a disposal well, that's a pretty big silver bullet. So are there other companies that are making a similar type of product? Who do you compete against?
Well, we compete against actually the metallic CRA tubing manufacturers. So companies like Tenaris and Sumitomo, those are our direct competitors. And I've been in this industry for quite a while, but I've yet to come across a company that makes this product, so a non-metallic tubing. And to be fair, that would also be quite difficult because we own the patents to the technology.
So I hear a lot about composite pipes and spoolable pipes, but that's not necessarily downhole, correct?
That's true. There are existing companies that do manufacture composite pipes. They also manufacture composite spoolable pipes. And to be honest, there's also a big boost in recent years in the application of those materials. But still, those companies and those products are very different from what we do. So companies that are in the market today, like Airborne or Magma, they have a very competent technology to make spoolable composite tubulars, but they do not have a capability to deploy those downhole. All their applications are subsea, so they make risers, they make jumpers, that kind of products. But we have yet to see them in the downhole area.
So what is it that keeps those other manufacturers of composites to go down inside the well? Is it temperature? Is it pressure? Or something else?
Actually, temperature is the biggest driver for that. The main distinction between what those established companies manufacture and what we do is that they use thermoplastic materials for their composites and we use thermosetting materials. And that's a very important distinction because thermoplastic, as the name already suggests, if you heat it up, it becomes plastic. And that is the way it's processed. You add temperature, you add heat, and then you can mold it into something else, which is of course a very handy thing to do. However, it also means that when the product is ready and you heat it up again inside a well, for instance, then again it becomes plastic. And that plasticity, even if you're using the most expensive materials available, it still means that at relatively modest temperatures, the performance of those materials are dropping, they deteriorate. And in order to avoid creep, for instance, which is often a result of temperature and some stress in a material, in order to avoid creep, they have to reduce the stress on the material, because the temperature is a given from the well conditions. For instance, the loading also from tensile loads or pressure loads, it's also a given. So all they can do is to reduce the stress is to increase the cross-section of a given design. And increasing cross-section means that you have to make your product bigger. And you can see that. The connections that are made by those manufacturers and that are made for those pipes, they are very bulky. And of course, that's a very elegant solution for a jumper or a riser, because it works, it's corrosion-free, it's cost-effective, but those connections, they simply do not fit into your production casing. So it's one or the other. Either you make the connections slim, you cannot stand the heat, or you make the connections big, you don't fit into the well. And
so it's not really fit for purpose.
Well, it's fit for their purpose, but not for
downhole purpose.
Correct.
So do you do all this by yourself, or do you have a team?
No, we have a team that I'm actually quite proud of. Of course, we are a very young company. We are only in business for a little over a year. And the core team exists of roughly 10 people with their own specialties and experiences. So we have a retired Shell guy, for instance, that is very helpful and has a myriad of experience that helps us along in this technology development. We have commercial people, we have a legal specialist that we have in-house, which I think is quite important, because there's loads of things that you have to deal with when you're starting up a new company, and just external lawyers are too expensive to do that for you. We have a brilliant PhD who is doing our composite analysis. He actually did his thesis on exactly this kind of product, on spoolable carbon fiber tubes, and everything related to that on a very advanced level is done by him. So yeah, there's a number of people that contribute to this effort, and each has their own very specific knowledge and contribution.
Very good. So you say the company's been around for about a year and a half. In what phase is this company in now?
We have basically gone through the design stage of the product, and we have done some initial testing. And what is in front of us today is much further testing, much more extensive testing to get the product field ready, so to speak. And that requires a very extensive test program. We have developed basically what I would call a simulation machine to simulate well conditions for the pipe and the connections at the same time. And in our case, those conditions are quite severe, because we are making a fairly high temperature product, which has to withstand high pressures and high tensile loads, and a combination of those loads as well. So the equipment that you need to test those conditions, if you pressurize water and you heat it up to 180 degrees C or 350 F, that is dangerous stuff to do at surface. So there is a lot of safety considerations built into that equipment, but it does allow us to precisely simulate the well conditions that the pipe will be exposed to. And that is actually the phase that we're entering into as of basically this summer.
Very good. So how do people learn more about CRA-Tubulars? How can they follow and participate in this journey?
Oh boy, we have loads of channels available for people to follow. Of course, the obvious ones like LinkedIn, and we have our website that people can log on to.